All right, great job, Casey. Thank you very much. Next up, we have Steve Hafel from Wisconsin. He's a Central Office HMA Supervisor. Steve has 36 years of experience in asphalt, 31 years with the Illinois DOT, and 5 years at Wisconsin. So Steve, come on up. Thank you very much. I'll give Steve a warm welcome.
Thanks, Randy. As he said, my name is Steve Hafel. I'm here to talk about the Wisconsin benchmarking effort. Got it. So to let you know kind of the road we traveled, back in 2014 and 15, we did some high recycle projects utilizing performance testing, kind of to see how that would help us use higher recycle. So we got onto the fact that we have to get on to doing the performance test and see how they work. Then in 2016, we actually hired an HMA specialist so we could start doing some testing. Worked great in 2017. Scott set up our testing lab. We remodeled an area, set up a testing lab, started testing, got it going. Unfortunately, he transferred. So 2018, 2019, we didn't have a specialist to do any testing. So the part about the staffing issues is real for us. 2020, we kind of reorganized some existing staff and we were able to get our testing going again. And we continue that in 2021. Some of our research projects that we have going on, obviously, we're also with the cracking group with the NCAT and Minroad, and we're involved in NRRA with Minroad and stuff. So we've got a lot of groups that we're teaming with to learn more about the cracking and other performance tests. But we did have a project back in 2016, the end of it, Dr. Bonnequist come up with looking at our different performance characteristics of our mixes, and IFE had just come out and he used the post-peak analysis and it really made the data work a lot better. So that was a big help. We had another project where we were looking at different performance tests. Dr. Bahia and the UW group found out that the 50 degrees for the Hamburg wheel did not work for our 58 minus 28 mixes. So that's one thing that we dropped that down to 46 degrees. And the next one NCAT did for us, the regressing air voids. And what we were at that time, Wisconsin was realizing we don't get enough asphalt in our mixes. They're too brittle. One of the regions actually said, we're going to try to fix this on our own. And they used an effective binder spec. We worked together with industry. Industry came up and said, hey, let's try regressing air voids. Other states are doing it. We actually regressed down to 3.0 voids. And that got another 3 to 4 tenths of virgin binder into our mixes. And that's all the testing that we've done has been on the regressed air voids. Another project with the UW and the team at Binky Materials and VitMix Solutions talked about the long and short-term aging. We verified we did want to do 4 hours of short-term aging to match plant mixed material. And we decided to go with 6 hours of long-term aging for our cracking test. Another NCAT project was to benchmark and develop a pilot spec for us. We gave them 18 mixes and they were able to kind of get an idea where our mixes laid and actually draft a little bit of a pilot spec for us. And this last one that we're just starting is pretty exciting for us because we are doing some of the things Randy talked about earlier. This is an NCAT project they're doing for us, and we're doing a field test section where we're going to have multiple sections where the upper layer is at different materials. It's the same mix design, but adjusted to have varying levels of cracking and rutting performance. And also we're going to do a bunch of jobs where we're going to take those 10 consecutive tests and go, how does this vary during production? If we change something during production, will it affect the results for our test? So which test? Everybody's semi-nightmare. We went with rutting test with the Hamburg wheel tracker. We're sticking with that so far. cracking, we've been kind of through the gamut with some SCV testing, and they didn't really pan out the way we wanted to when we found out the post-peak analysis was better. We did do some DCT, and right now that's kind of parked. Of course, thermal cracking is important to us up in Wisconsin, but we have made some binder changes to help that. The IFIT is what we started doing, and then we pushed the easy button with the ideal CT and said it's basically a similar process. So we went and that's what we've been testing the last 2 years with is ideal CT. And we had to set up our lab. We had the Hamburg wheel tracker equipment, and then we also have an Instratech chambered, so with a horizontal jig we can run DCT and other tests. Temperature controlled there, and we also have the vertical jig that we can do our ideal CT, our room temperature testing at. So as we go to benchmarking, a lot of details, devil's in the details, as they say. So here we are. What mixes are we going to sample? What tests are we going to complete? What protocols are we going to use? How do you collect and store the data? We've had to go through a lot of those issues the last couple of years. So we did test in 2017. And then again last year, and we're continuing this year. This is just a breakdown based on traffic level, our low traffic, medium traffic, high traffic, and also SMA that we use on a lot of our, some of our interstates. We're trying to push that more now. And you can see MT is our workhorse. We've got most of those mixes there. And as we break down those 2020 mixes, you can see not only the traffic level, but also look at the binder modification level. It's the M332 designation, so it's standard and heavy, very heavy, extreme binder grades. And you can see we've got the S grades covered pretty well, especially the MT, but we need to make sure we fill in those other data so we can understand the performance gain we're getting with other modifications. So the mixes we benchmark were primarily from our PWL projects we had. We have PWL as our highest level quality. It actually has a test strip, so we know we get the mix lined in. We go a couple days, the mix is going good, and then we'll go out there and sample it. Our contractor partners are out there sampling a bunch of boxes for us and for them. We also locate these location of those samples. So we know by a northbound lane at these coordinates, that's where this sample test is located. So hopefully we can get that, long-term performance tied down, because we don't have really any of that now, but at least we'll have some references in the future. We also are trying to key on other select mixes, like I said, SMAs, interlayers, and try to get more mixes with polymer so we can help fill that data set up. So as far as the tests, when we get those splits from the contractor, the regions are grabbing them for us and sending them to the central office. That's the only place that the department's doing any performance testing. We have the Hamburg wheel, so we're running only plant mixed basically right now, with no additional aging for Hamburg wheel, whereas the ideal CT, we are doing additional aging to the 135C at 6 hours. That's what we're doing right now, hopefully to vet out the aging of the binder, and especially if recycling agents come to be. We've also done some without the additional 6 hours of aging. We want to get that comparison. We understand a lot of states are looking at just the plant mix or short-term age mix to try to use that easier for production testing. So we are looking at that. So keep that in mind as you look into our numbers. There's some numbers that are over 50 typically, and they might be just plant aged or short-term age materials. Ours are the minimum ones are below 50, and that's why our levels is lower, or half as much as what you saw yesterday. So the database, it's quite a thing to look at once you get all the numbers in there, and you're always wanting to add more columns, but it takes a lot to get the DOT and contractor data in there. You got to identify the test and the testing conditions. And we're also adding some automated analysis to it, so we can go and get our average and standard deviations out of it. We're plotting histograms and doing those cumulative distribution plots, S curves that we saw in the research that NCAT did for us. So they're coming in pretty handy. So the database right now has 51 columns, a lot of project info, like the county the project's in, and information of the location of the test, the mix info, the gradation and the type of binder and such, and other properties too, like the aggregate type and in the source actually also. We also have the Hamburg wheel tracking info and the results for that, the ideal CT info and results. Our old database, we actually had all those other tests we were trying. So the current one is cleaned down to just these tests. And of course, comments section in case there was, the testing was part of another NCHRP project or something we've had in the past. We are trying to make it simpler. We're going to start implementing a form for the contractors to put all their information in for their testing. They can send it to us and we can auto-populate our database with it. And then we can easily compare our test to the contractor's test. One way when we're looking at Hamburg wheels is you're always looking at the number of passes or maybe the rut depth if it exceeds the 20,000. And we've got the full gamut of the degrees of rutting. So what I asked our staff to look at is drawing out that bottom axis. So it's actually two axes in one. We've got the Hamburg wheel passes, from 0 to 20,000. And for those mixes that do make the 20,000 passes, we've added a more continuum of the scale. It's very simple. All we did is add another 1,000 passes for every millimeter rut depth to be below 12.5. So I hope that doesn't upset the scientist in you, but it actually works pretty good because now we can see the continuum of the test and the spread of rutting resistance that we really have. Initially, we were looking at like a 40 CT index. As you can see, there's a lot of mixes below that. And remember the CT index is the plant mix plus the 6 hours of 135 aging. And the Hamburg wheel is only plant mixed or short-term aged. So there is a considerable amount of concern for our cracking resistance. And there is some concern. We had one HT binder that we would have liked to see make 15,000 passes. It didn't, and several the low traffic mixes are the S binder mixes that did not meet that line. So that's the ones we looked at, but you can see we kind of got that continuum from the upper left to the lower right. And the sweet spot is upper right is where we want all of our mixes if possible. This is the same thing, only instead of using binder grade to get the different thresholds for Hamburg wheel, we're actually using our traffic levels. And it doesn't, Hamburg wheel trends much better with binder than it does with, the traffic level, especially in our case where we have areas in the state where we have outstanding aggregate structure. And so those LTs and MTs, the same aggregate is used as HT, so they can perform very well all the way along the continuum. So that's why they're spread out. Our HTs are up there where they belong though. So we did set up a pilot special provision that we hope to have. We're going to try to get it on all 5 of our regions completed by next year. So we're only going to do 5, kind of just sticking our toe in the water. We are definitely taking baby steps. When you're in DOT for 36 years, you tend to be pretty conservative. And so we're taking steps to move toward it. We have Hamburg wheel and the ideal CT and the pilot spec. And the criteria we used was similar to what you saw there, the 10, the 15, and the 20,000 for the S, H, and V binders, and the E also. And we have the ideal CT. We're looking at using 30 at first to try to get capture our worst cracking susceptible mixes. And we also added in the stripping inflection point of 8,000. If you look at that plot, it kind of gives you a better idea for the 30 for the ideal CT, those mixes that are below it, we end up failing about 15% of them right now. The 40 was higher. We could have went with that. We're trying to get a balance to work on our worst mixes. Industry understands that we're going to have some mixes that we have to fail, otherwise this process isn't worth it. But again, we don't want to fail all of our mixes and impact a lot of designs at a time. Then as we look at the Hamburg wheel, you can see that the H binder mix, along with several of those LT or S binder mixes, did not meet the design criteria or the criteria for the Hamburg wheel passes. I wanted to take note of that circled one, because if you really look at the Hamburg wheel and the SIP, that circled one is the only one that failed SIP also over the Hamburg wheel ones. So all the Hamburg wheel that is less than 10,000 failed on the number of passes and the SIP. And then there's another additional point on the SIP that failed. And if you can see that point, the mixed design F there, that one actually slid in there in the number 6 spot for the SIP. Otherwise, since this analysis is basically similar, you're looking at, they're showing us probably that we have a rutting or a stripping problem, maybe more than a rutting problem. We're going to look at this also. We're working with FAN now to try to use that analysis for the stripping number and the rut depth. So we're going to see if that tells us anything more, and try to understand, is our rutting problem, our concern, really a stripping problem? And it very well might be, because several of these mixes are in an area that we know we have stripping aggregates in that part of the state. So we might have more of a stripping problem, and we definitely have a cracking problem. It was good to have all these points and to get a good big picture view of them. And remember, this is all data that after we regressed our air voids to 3%. So if we would have done our 4% mixes, I'm sure we would have had more of them that would have been down and to the right and more cracking susceptible. So those are the results of our starting our benchmarking efforts. We're trying to keep things going. We realize, with Randy's list that they've been working on with the FHWA, we're going to look at that closer, this coming fall and winter, to see what steps do we need to take. But we need to do a lot more analysis on this data to try to get where we're at, and a lot more data points too, and especially in those modified areas. That's all I have on my presentation. If we have any questions.
That was some great stuff you had there. And I think one of the things that I think was really key, and it was in the data, is that you regressed your air voids. So now you have that little bit higher binder content than you normally would have in the past. There's been a lot of discussion about, we put polymers in some of these tests on identifying the improvement with polymers. But there's a catch to that. You have to have enough binder in the first place. So if I don't have enough binder, I can put the best binder in the world, it's still going to crack. So I think, some of your data clearly shows that it's a combination of both. I got to have a good binder and enough of it. And, and it's the one that you're always balancing. I can take a crappy binder and put more of it in, I'm going to get better cracking. But maybe if I had a really high quality polymer modified binder, I'd even get superior, but I can get both. And I think your data goes a good first step to show really that key thing there.
Thanks. Yeah, clearly that, we've had some data to the right that was very rut resistance, but some was very elevated. So we know that we're getting good crack resistance to it. So we've really got to identify what's going on with that material that it was so elevated in cracking resistance.
Hi, Steve. I had to promise Randy that I would be short so I could approach the microphone again. Thanks for the great presentation. I think, in agreement with what John said, and I think, the data showed some very interesting trends. So thanks for that. I'll just maybe keep a short statement on this. Do you think it would be a good idea for maybe folks that are putting together databases of ideal data, yourself or others, that we, just start putting maybe a small piece of data entry in our report page that says, did the sample, crack in 2 pieces in tension, or did it, have, three-piece failure, with a shear failure essentially. planes on it. Was there bulging under the loading heads, or was there not? Was there compression damage? I think at some point we're going to come back and want to look at, whether we need to do other temperatures, whether we need to maybe separate the criteria for samples that fail in pure tension and those that don't. And I think that will save us a lot of retesting if we just capture that, maybe in a numeric 0, 1 or a scale or something right now. And later on, we'll just have it, or we won't use it, but I don't think it adds a lot of extra work.
Yeah, that's a good point. Is we always look at the number and get the quantity, but we don't have like the characteristic or quality of the result. And we don't track that. We are, we're grabbing something and trying to, get the testing done and kind of the dust settles. And then you go back and look at the data and you realize, oh, I wish we would have done this and wish we would have done that. And every state, I'm sure, is going to go through that as they go through this process. And that might be something that we wish we had. I don't know.
Yeah, it'll just add, 10 seconds to the data entry today, and maybe we'll need it later. Thank you.
Yep.
Hey, Steve, thanks very much for the great presentation. A few questions and comments coming from online attendees. A question from Chris Wong asking, have you considered differences in plant aging for mixes with warm mix asphalt?
No, we haven't. And it does present a concern, is the warm mix and what type of warm mix it is. And I think we do have to look at that. A couple of the mixes that were on the less passes, they are warm mix and stuff. And we don't know if the warm mix chemical still was activating there and making that mix softer or not.
Next question from Oak with Montana DOT asking specifically about the Humber wheel tracking test. How are you calculating stripping inflection point? Are you using whatever equation or equipment is using, or are you evaluating it externally with some other polynomial function, for example, using our DOT equation? I think that's something we discussed briefly yesterday. So.
Yes, we are using the Instratech results and stuff, but we are comparing that to the Iowa one in some instances, and we haven't seen much difference. So we haven't done all of it through the Iowa analysis.
The next question from Hada, asking specifically about the long-term aging, as you mentioned, like the 6-hour 135C. So have you considered the mixture thickness during aging? And also, what is the reason behind selecting this specific aging protocol for long-term aging?
Well, we did want to get something so we could affect the binder aging and stuff like that. And there is a protocol spelled out to put it in a pan 1 inch thick and everything. So that is somewhat set on that aging protocol that we have. And it was just through the research project. We did a couple different times and said that was an important factor to get us a reasonable cracking test result. And it definitely was much different than the non-aged material or the non-long-term aged material.
The next one is more about the comments. Great to see so much data has been collected. A big takeaway seems to be that there will be a large difference in what the minimum ideal CT specification should be. For example, man was saying like 140, Wisconsin was talking about 30. It really illustrates the need for each agency to do the benchmarking piece to better understand what is appropriate for their own mixes, binders, and climate, not just take a number from someone else and implement in your own states.
Exactly. That's when you hear from different people and we have numbers all over the board, you do need to take into account, what their aging protocols are, and then, what are their normal materials. And we are seeing cracking. So we still believe we probably will have a cracking problem, considering we had a bad cracking problem before we went through air void regression. But, we're going to have to try to improve the cracking resistance, and you don't want to throw out every mix design the first time through.
Yeah, I agree. And also, I guess just for clarification, like Wisconsin, when Steve was saying like a 30, that's after long-term aging. So that's a little bit different from what other state has been talking, which is based on short-term aging. And also, I fully agree with what Steve said. It's, when we talk about ideal CT testing and criteria, we need to also specify the aging condition. Even the short-term aging can be different. So some states do 4 hours at 135C, some states do 2 hours at compaction temperature. And that can be a huge difference in terms of CT index results. So we're not, trying to compare apple to apple if, all these agents are different. All right, I'll give the spot to you.
All right. Yeah, just kind of on that topic, I was curious, you mentioned that you were looking, I think, at that offset from the long-term aging with the 6 hours versus plant aged. I was curious if you could maybe provide a little more detail of what you're seeing because of that significant difference in criteria. And then also you mentioned the possibility of being able to use an offset like in acceptance possibly in the future if maybe you're monitoring if that offset's staying pretty similar across like a production run. Just wanted to see if you could share any more on that.
It
Brett
was,
Williams, sorry, Napa.
thanks, Brett. It was very confusing when looking at it because a lot of the data is half as much as the plant mix material, and a lot of data is fairly close. So it doesn't appear that you can just say, take your plant age material and multiply it by 0.6 and that's your answer. It probably is going to vary from 0.5 to 0.8. And so we've got to identify why those materials that had 0.8 and why some other materials had 0.5. And, we're talking about plant aging yesterday in the silo, and maybe those mixes that didn't change a lot were aged in the silo already and had some of that earlier aging done. I don't know, but there is not an easy answer from the data we have just looking at it. We haven't really analyzed it and what's the difference between some that don't drop very much to those that drop in half, consistently. So that's not going to be an easy one as far as I can see on the surface.
All right, thanks very much, Steve.